All right, get ready to dive deep into Ethereum.
Ooh, exciting.
We're going to unpack some serious knowledge from Mastering Ethereum
Yes.
by Andreas M. Antonopoulos and Gavin Wood.
Great book.
You know, we're going way beyond the basics here. This
Yeah.
is about truly understanding how Ethereum works.
It is, yeah.
So it's like getting that backstage pass, right?
Absolutely, yeah.
You're going to see how the EVM,
Sure.
that's the Ethereum Virtual Machine.
Yeah, okay.
That's the world computer.
Right, yeah.
It's going to show you how that actually runs your code.
That's going to be really interesting.
I know you just created your first smart contract
Yes.
on the Ropsten testnet.
Yes.
So we're going to be using your experience with that
Right.
to make these concepts really click.
Awesome. Looking forward to it.
Okay, so first things first.
Yeah.
Let's get our heads around some Ethereum basics.
Course
We've
it is.
got Way, denominations, wallets. There's a lot to unpack here.
Oh, yeah, especially Way.
Yeah.
Way always seems to trip people up initially.
I know, it's kind of a weird word.
But it makes sense when you think about it.
Yeah.
It's the smallest unit of ether.
Okay.
And it's crucial because of gas.
Uh-huh.
You see every action on Ethereum,
Right.
every transaction, every line of code in your smart contract,
Mm-hmm.
it costs gas.
Okay, so Way is like the pennies of the Ethereum world.
Exactly.
But why go so small? Why not just use Ether as the base unit?
That's a great question.
Yeah.
Imagine if the smallest unit of money you could use was $1.
Hmm.
Buying a piece of candy would cost at least $1, which isn't practical.
True.
So Way allows for incredibly small transactions,
Oh, okay.
which is essential for things like micropayments and especially covering the cost of gas for complex smart contract operations.
Right. Okay, that makes a lot more sense now.
Good.
So speaking of wallets,
Yeah,
the book really hammers home the importance of security.
it does.
Absolutely no digital copies of that mnemonic phrase, right?
Absolutely not.
Pen and paper only?
Pen and paper, that's the way to go.
Yeah, like old school,
Yeah.
because your mnemonic phrase is like the master key to your Ethereum kingdom.
It is.
It's like losing the keys to Fort Knox.
Exactly.
Only there's no backup vault in the crypto world.
No, unfortunately not.
That's why the book emphasizes cold storage,
Yes.
keeping those keys offline and secure.
Secure. That's the most important part.
Yeah, it's a good reminder to be extra careful.
Yeah.
Now let's move on to Solidity,
Okay.
the programming language for smart contracts.
Right.
You've already dipped your toes into it,
I have, yeah.
but the book dives deeper into the logic behind it.
Mm-hmm.
For example, it talks about the difference between imperative and declarative programming.
Yes.
I mean, can you explain that a little?
Sure. So Solidity, like many other languages, follows the imperative paradigm.
Yeah.
You're essentially giving the computer step-by-step instructions on what to do,
Okay.
like writing a recipe.
Mm-hmm.
First do this, then do that, and then check this condition.
Okay, so unlike a declarative approach where you just describe the desired outcome,
Right.
in Solidity, you're guiding the process every step of the way.
Exactly.
I can see how that level of control is important when dealing with things like financial transactions on the blockchain,
Absolutely.
where things need to be super precise.
Yeah,
So Solidity gives you those tools
it does.
to write those clear and concise instructions,
Mm-hmm.
utilizing data types like integers,
Yeah.
and of course Way for handling those tiny units of ether.
Exactly. We've got to have those Way.
Right, and those unit multipliers, like
Yeah.
using ether instead of writing out a huge string of Way.
Oh, yeah, much easier.
That makes the code so much more readable.
It does. Readability is key.
Yeah, and smart contract development.
Yeah.
We want to avoid any ambiguity that could lead to errors or vulnerabilities.
Exactly.
Speaking of vulnerabilities,
Oh,
the book spends a good deal of time
it does.
on security considerations. I know you use the only owner modifier in your faucet contract,
Yes, I did.
which is a great example of how Solidity helps you enforce rules and control access.
It is, yeah.
So can you talk a bit about modifiers?
Sure. So modifiers are essential for building robust contracts.
Yeah.
They act like gatekeepers,
Right?
ensuring that only specific actions can be performed under certain conditions.
So in your case, the
Yes.
only owner modifier ensured that only you, the contract creator,
Yes.
could trigger certain functions.
Correct.
It's like having a security system in place.
It is a very important one.
But the book also highlights some common pitfalls
Yes.
that developers need to watch out for, like
Ugh.
reentrancy.
Yeah, that's a tricky one.
So can you explain that a bit more?
Okay, imagine a malicious contract that calls your contract's function to withdraw funds.
Oh.
Now, let's say your function before updating the balance,
Yeah.
makes a call to the malicious contract. That malicious contract can then use this call as an opportunity to re-enter your function
Oh.
and withdraw funds again before the balance is properly updated.
Oh, wow.
It's like a sneaky double dip.
So it's like a malicious contract hijacking the flow of execution?
Exactly.
That sounds dangerous.
It can be very dangerous.
So that's why it's so important to understand these potential attack vectors.
Absolutely.
Luckily, the book provides practical guidance on how to prevent reentrancy and other common vulnerabilities.
Yes, it's very helpful for that.
So you also use events in your faucet contract.
Yes.
Can you remind us why events are so important for smart contracts?
Sure. Events are like breadcrumbs, leaving a trail of what happened within a contract.
Okay.
They allow off-chain applications to track specific actions,
Right.
providing transparency
Okay.
and making it easier to monitor and audit the contract's behavior.
So they're like a built-in logging system.
Exactly.
All right. I think we've covered a good chunk of the Ethereum basics.
Yeah, we're getting there.
We've got Way, providing the granularity for gas costs and microtransactions, secure wallets safeguarding our precious keys,
Very important.
and Solidity giving us the tools to write safe and efficient smart contracts.
It's a great language for that.
It is, and it's important to remember that even though we're diving into the technical details,
Yes,
this is all ultimately about building a decentralized future.
absolutely.
Ethereum provides the foundation,
Yes?
and Solidity is the language we use to create the rules and functionalities of that future.
The building blocks.
All right, now that we've got a grasp on the foundation, are you ready to journey to the heart of the Ethereum machine?
I am. Let's go.
Then prepare to enter the EVM, the Ethereum Virtual Machine,
Right.
the engine that powers all of this decentralized magic.
Sounds awesome. The EVM is where those lines of Solidity code you wrote become actions on the blockchain.
Okay.
It's like a global decentralized computer with its own set of rules
Right.
and a very specific way of doing things.
Oh, wow. So what happens to my Solidity code when it enters this virtual machine?
First,
Yeah?
your Solidity code needs to be translated into a language the EVM understands.
Yeah, okay.
That's bytecode.
Bytecode.
It's a low-level representation of your contract's logic, broken down into individual instructions called opcodes.
So it's like compiling a recipe
Yes.
written in plain English into a set of precise commands for a very specific cooking robot.
That's a great analogy.
I like that.
Each opcode tells the EVM to perform a specific action,
Okay.
whether it's adding numbers,
Mm-hmm.
storing data, or sending ether.
So the book gives examples of how these opcodes work,
It does.
showing how they manipulate the EVM stack, memory, and storage.
Yep, all of that.
Wow. So my relatively simple faucet contract gets broken down into this intricate dance of opcodes.
It does. It's pretty fascinating.
And then remember gas. Every single opcode execution consumes gas.
That's right.
That's why writing efficient Solidity code is so important.
Very important.
The more complex your contract's logic,
Mm-hmm.
the more gas it will consume,
Yes.
and the more it'll cost to execute.
Exactly. It's like paying for each step in the recipe.
Right.
And those fancy gourmet steps.
Yeah.
They cost more than the basic ones.
I like that analogy. Now, the book also mentions something about disassembling the bytecode.
Yes.
What's that all about?
Disassembling is like reverse engineering the recipe from the robot's commands.
Oh.
Tools like Binary Ninja with the Ethersplay plugin
Uh-huh.
allow you to take that bytecode and break it down into those human-readable opcodes,
Right.
giving you a deeper understanding of how the EVM is actually processing your code.
So for those who really want to get their hands dirty,
Yes,
they can dive into the nuts and bolts of the EVM
it can.
and see exactly how their code translates into these low-level actions.
Exactly.
So it's like peeking behind the curtain to see the wizardry at work.
It is.
But even without disassembling the bytecode,
Uh-huh.
understanding the EVM's role is crucial for any Ethereum developer.
It is, absolutely.
Now let's zoom out a bit
Okay.
and talk about the bigger picture.
Right.
Ethereum is currently undergoing a major transition
It is.
with its consensus mechanism.
Right.
The book explains that it's moving from proof of work to proof of stake.
Yes, big change.
Can you tell us a bit more about that?
So right now, Ethereum uses proof of work,
Okay.
where miners compete to solve complex mathematical problems,
Uh-huh.
to secure the network and add blocks to the blockchain.
Mm-hmm.
It's like a giant
Mhm.
energy-intensive race.
Right.
But it's not the most efficient
Right.
or environmentally friendly approach.
So proof of stake is like finding a more sustainable way to keep the network running.
Exactly.
Okay.
With proof of stake. Instead of miners, we have validators who stake their ether to participate in securing the network.
Right.
Think of it like posting a bond.
Okay.
The more ether you stake, the greater your influence in the consensus process.
The book mentions Casper as the name for Ethereum's upcoming proof-of-stake system. It sounds like a big change.
It is a big change.
And it has the potential to make Ethereum more scalable.
More secure and energy efficient.
So Casper is still under development?
It is.
But it represents a significant evolution for the Ethereum ecosystem.
It does.
It's exciting to see how Ethereum is constantly evolving and improving.
Always changing.
Now on to another exciting aspect of Ethereum.
Okay.
Tokens.
All right.
I know you've been experimenting with creating your own tokens.
I have, yes.
The book dives into the world of ERC-20 and ERC-721 tokens.
It does.
Can you refresh our memories on the differences between them?
Sure. So ERC-20 tokens are fungible, meaning they are interchangeable.
All right.
One token is just like any other token of the same type, like dollars or bitcoins.
Okay.
You used this standard when you created your Me token.
Yes.
Which is great for representing things like virtual currencies or loyalty points.
And then we have ERC-721, which represents non-fungible tokens or NFTs.
Yes.
These are unique.
They are.
And can represent one-of-a-kind digital assets, like digital art, collectibles, or even virtual real estate.
That's right.
Each NFT has its own distinct characteristics and value.
It does.
Making them ideal for representing ownership of unique items in the digital world.
Absolutely.
Remember that virtual auction DApp we discussed?
Yes, I do.
That utilized ERC-721 tokens to represent digital deeds for those virtual properties.
That's right, it did.
So ERC-20 is like creating a new currency.
Yes.
And ERC-721 is like minting unique digital artifacts.
Exactly.
It's amazing how Ethereum enables these different forms of digital ownership.
It is.
It really opens up a world of possibilities.
It does.
And it's not just about these two standards. New token standards are constantly being developed.
All the time.
Each with its own unique properties and use cases.
That's the beauty of it.
The book also cautions against the potential pitfalls of tokens.
It did.
Like accidentally sending them to a contract address that doesn't support them.
Yes, that's important.
Unlike Ether, which can be sent to any Ethereum address.
Right.
Tokens reside within the logic of their respective smart contracts.
That's right.
Sending tokens to an incompatible contract is like sending a letter to the wrong address.
Exactly.
It might be lost forever.
It could be.
So it's a good reminder to double-check those addresses.
Always double-check.
The book also touches upon the world of ICOs.
Yes.
Or initial coin offerings, where tokens are often used for fundraising.
That's right.
What are your thoughts on that?
ICOs can be a powerful tool for innovative projects to raise capital.
Okay.
But it's important to approach them with caution. The book wisely advises doing your due diligence.
Right.
Thoroughly researching the project, the team, and the technology before investing in any token offering.
It's like any investment.
It is.
Understanding the risks and potential rewards is crucial.
Absolutely.
Now let's shift gears and talk about oracles.
Okay.
The book explains how they bridge the gap between the blockchain world and the real world.
They do.
Think of oracles as data providers for smart contracts. They bring in information from the outside world, like stock prices, weather data, or even the results of sporting events.
All kinds of things.
So if a smart contract needs to know the current price of gold or the outcome of an election, it can rely on an oracle to deliver that information.
That's right.
Okay.
Oracles expand the capabilities of smart contracts, enabling them to react to real-world events and data.
The book mentions Oraclize as a popular Oracle service.
It is a popular one.
I'm curious, how do you actually integrate an Oracle into a Solidity contract?
Oraclize provides a straightforward way to request and receive data within your Solidity code. You essentially send a request to Oraclize, specifying the data you need, and then your contract waits for Oraclize to deliver the requested information.
So it's like making a phone call to a data expert. Yes.
And waiting for them to call back with the answer.
Pretty much.
Okay.
Oracles provide a reliable and secure way to bring real-world data onto the blockchain.
Right.
Which opens up a whole range of possibilities for smart contract applications.
Okay, we've covered a lot of ground here.
We have.
From the inner workings of the EVM to the broader landscape of consensus mechanisms, tokens, and oracles.
Lots of information.
It's amazing how much complexity and innovation is packed into this decentralized world.
It is.
And as the book emphasizes,
yes,
this is just the beginning.
It is.
Ethereum is constantly evolving with new ideas and technologies emerging all the time.
All the time.
It's exciting to think about what the future holds.
It is.
Now, before we wrap things up,
okay,
I wanted to touch on a concept the book mentions.
All right.
The immutability of contracts.
Yeah.
Once a contract is deployed, its code is set in stone, right?
Right.
But what if there was a way to create contracts that could adapt and change over time? That's a fantastic question.
Yeah.
And one that researchers are actively exploring.
Oh, really?
Upgradable contracts, as they're often called,
Okay.
represent a significant challenge. But they could unlock a whole new level of flexibility and functionality for decentralized applications.
So it's like the difference between carving something in stone
Yeah.
and building with Legos.
Exactly.
With upgradable contracts, you could potentially fix bugs,
Yes.
add new features, or even respond to unforeseen circumstances.
Right.
But the challenge lies in finding a way to do this while preserving the security and trustless nature of blockchain technology.
Absolutely.
So there are various approaches being explored.
There are.
Each with its own trade-offs.
Always trade-offs.
It sounds like a complex puzzle.
It is.
The book has given us such a great foundation for understanding the core concepts of Ethereum.
It has.
And it's intriguing to think about how these ideas could be pushed even further in the future.
Yeah, it really highlights the dynamic nature of this space. Ethereum isn't a static platform.
Right.
It's constantly evolving and adapting.
So mastering Ethereum equips us with the knowledge to understand not just where Ethereum is today, but also where it might be headed tomorrow.
Exactly.
Now, looking back at everything we've covered, what stands out to you as the most significant takeaway from this deep dive?
Well, for me, it's the realization that Ethereum is more than just a technology. It's a movement.
Yeah.
It's a community of developers, entrepreneurs, and visionaries building a decentralized future where power is distributed and innovation is unleashed.
And you, having built your first smart contract, you're now a part of that movement.
I am. It's pretty exciting.
It's inspiring to see how this technology is empowering individuals and communities to create new possibilities. And that potential is only going to grow as Ethereum continues to evolve. The shift to proof of stake, the emergence of new token standards, the development of more sophisticated tools and applications.
It's an exciting time to be involved in this space.
It is.
Mastering Ethereum serves as an excellent guide, not just for understanding the technical details, but also for grasping the philosophy and vision behind this revolutionary technology.
Absolutely. And as we wrap up this deep dive, I want to leave you with a final thought to ponder. We've talked about how smart contracts can automate agreements and transactions. But what happens when those agreements involve real-world events that are difficult to verify on the blockchain?
That's interesting.
For example, imagine a smart contract that pays out insurance claims based on weather data. How can we ensure that the weather data provided to the contract is accurate and trustworthy?
Well, that's a great question. And it highlights an area where oracles play a critical role. In your example, a decentralized weather oracle network could provide reliable and tamper-proof weather data to the smart contract, ensuring the validity of the insurance claims.
It's fascinating to think about how these different pieces of the Ethereum ecosystem, smart contracts, oracles, decentralized networks, can be combined to create innovative solutions to real-world problems.
It really is.
It's a testament to the power of this technology and the creativity of the community behind it.
Absolutely.
So there you have it, your deep dive into the world of Ethereum.
We did it.
We journeyed from the smallest unit of way to the grand vision of a decentralized future, exploring the intricacies of the EVM, the elegance of Solidity,
It is elegant.
and the transformative potential of Dapps, tokens, and oracles.
So much potential.
Remember, this is just the beginning of your journey into the decentralized world.
Just start.
Keep exploring.
Yes.
Keep experimenting and keep building.
Build, build, build.
Until next time.